Okay, I'm giving you the class instead of Dr. Osama because he has another meeting now. Okay, I am Amna. We stopped last time at slide 29, right? Are you seeing my screen?
Yes.
Yeah. We go back to slide 28 to see the TCP/IP protocol suite. And what is the difference between TCP/IP and OSI? And we said that the layers in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having 4 layers, which are host to network layer, internet, which is network layer, transport, and application layer. However, when TCP/IP is compared to OSI, we can say that the TCP/IP protocol suite is made of 5 layers, which are physical layer, data link layer, network layer, transport layer, and application layer. So in the next slide, we see these 5 layers. And we will have an idea about each protocol in these 5 layers. Look at not the gray color. The first from up to low, from up to down. The first one is the application layer, then the transport layer, then the network layer, and then that physical layer, which is combined data link and physical layer of OSI model. And the first one, combine application presentation session. All these are called application layer. Okay? So what are these protocols? We will have an idea about these protocols in the TCP/IP protocol. In the application layer, which includes the protocol used by most applications for providing user services or exchanging application data over the network connections established by the lower level protocols. This may include some basic network support service, such as routing protocols and host configuration. Examples of these protocols in the application layer, the SMTP, which is Simple Mail Transfer Protocol, FTP, which is File Transfer Protocol, HTTP, which is Hypertext Transfer Protocol, and DNS, which is the Domain Network System Protocol. This protocol helps internet users and network devices to discover the websites using human reliable host names instead of numeric IP addresses. The SNMP protocol, which stands for Simple Network Management Protocol. This one enables network management. And the last example is the Telnet. The Telnet protocol provides a standard method for terminal devices and terminal-oriented processes to interface. The second layer from up to down is the transport layer. In the transport layer, we can see STCP protocol, which is Stream Control Transmission Protocol. Stream Control Transmission Protocol is a computer network communication protocol in the transport layer. TCP, which is Transmission Control Protocol, is a communications standard that enables application programs and computing devices to exchange messages in this layer over the network.
Doctor,
Yes?
sorry for interrupt you. Okay. We just lost your slide, and it's good now.
Any question you can ask. Are you seeing my slide?
It's just
Okay, everything is clear. I'm just telling these abbreviations about the protocols, giving you what this protocol stands for. And then I can send you the document, okay?
Doctor.
Okay. Then in the transport layer, we have the third example, which UDP. UDP stands for User Datagram Protocol. This is a communication protocol used across the internet for especially time-sensitive transmissions, such as video playback. The next layer is the network layer, the third layer in the TCP/IP model. The network layer has some example protocols like ICMP. ICMP stands for the Internet Control Message Protocol. The other one is IGMP, which stands for Internet Group Management Protocol, which manages the membership of hosts and routing devices in multicast groups. The third, which is RARP, stands for Reverse Address Resolution Protocol. This is an obsolete computer communication protocol used by client computer to request its internet protocol like IPv4. The last example protocol in the network layer is ARP, which stands for Address Resolution Protocol. This protocol or procedure that connects an ever-changing internet protocol addresses to a fixed physical machine address. It's also known as Media Access Control, like MAC address. In a local area network. In the data link layer and data link and physical, which is called physical layer, in this layer, which is the down layer, protocols defined by the underlying network, like host to network. I give you the example of, now just we can figure that what are the 4 layers of the TCP/IP and which layers it combines from OSI model. Some examples from of the protocols which are used in each of these layers. The abbreviations, I will send you the document, okay? I'll send it to Dr. Osama to send for you. Okay. Next, we are going to learn about the addressing levels. So in each connection, we have to know, or the computers, the devices, need to know the addresses. The sender, how the addresses happen from the sender to the receiver. There are four levels. Four levels of addresses are used in an internet employing the TCP/IP protocols, which are physical addresses, logical addresses, port addresses, and specific addresses. We are going to learn about these levels of addresses. Okay, we can see based on the layers in the application layer, what is the level of addresses? It is specific addresses. In the transport layer, the devices use the port addresses. In the network layer, the devices use the logical addresses. And in the physical layer, physical addresses. How these levels of addresses look like? We are going to see an example. Oh, before this, let's have some idea about these addresses. Go back here, yes. The physical addresses, also known as the link addresses, is the addresses of node as defined by its LAN or network. LAN or WAN. The size and format of these addresses vary depending on the network. For example, Ethernet uses 6 bytes, which equal 48 bits physical address. Physical addresses can be either unicast, which means one single recipient, or multicast, which means group of recipients, or broadcast, to receive by all systems in the network. Most local area networks uses 48 bits, which equal 6 bytes physical addresses, written as 12 hexadecimal digits. We will see an example. The logical addresses are used by networking software to allow packets to be independent of the physical connection of the network. That's to work with different network topologies and types of media. A logical address in the internet is the internet currently 32 bits addresses that can uniquely define a host connected to the internet. Like IP address we can see when we set our connection. The port address. There are many applications running on the computer. Each application runs with a port number on the computer. Each application, like your browser, your Google Chrome browser, have a port number. This is what we mean port address. A port number is a part of the addressing information used to identify the senders and the receivers. So your application which you are using to send, for example, WhatsApp has a port number. WhatsApp is an application, has a port number. Google Chrome browser has a port number, and this number included in the address for the sender and the receiver. Port numbers are most commonly used with TCP/IP connections. These port numbers allow different applications on the same computer to share network resources simultaneously. So I can use the browser, the Explorer, the WhatsApp, the Telegram app in the same time, connecting on the internet. Why? Because each app has different port number. Understand?
Me, sorry, we cannot see the slide.
Yeah. I didn't hear. I didn't hear. What? Please repeat. Bismillah. The application specific address, which is the higher level. Some applications have user-friendly addresses that are designed for the specific application. Examples include the email addresses. You know this one, you know this example, the email address, and the universal resource requested URL. We use URL always for as an example of the application specific addresses, right? When we say the application specific addresses like email address, like URL, okay? Then let's go through an example of how we use these addresses, how the devices use these addresses through the connection process. In this example, in figure 219, a node with physical address 10 sends a frame to a node with physical address 87. The two nodes are connected by a link, which is the bus topology of the LAN. See? The sender, which has physical address number 10, sends a frame. We said in the data link layer, we send frames. Send the frames to another physical address 87. Look at the other side of the figure. 87 is the receiver. And the address of the receiver is also in the header of the frame, as you see. The sender and the receiver in the address. The two nodes are connected by a link, which is the bus. This one, the blue, the red, and the black line, which is the bus, goes through the bus of the LAN topology. As the figure shows, the computer with physical address 10 is the sender, and the computer with physical address 87 is the receiver. So through this bus, the bus of the LAN, if there is other nodes like 80, 28 or 53, do they receive the packet or the frame? No. They are not the destination address. If there is no match for the destination address, then the packet is dropped until it delivered to the destination address, which is 87. And this number is in the header of the frame. Did you got? This is what we mean by physical address. Did you got it?
Yeah, doctor.
The example is clear?
Yes.
Okay. So as we said, most local area networks, LAN stands for local area network, uses 48 bits, which equal 6 bytes, right? Each byte equal how many bits? The 1 byte contain how many bits? This is out of the lecture. This is based on your background. In your background, what is the smallest unit of memory?
Okay.
The bit, yes, the bit. Then the byte. The byte equals how many bits?
8.
8, right. Each byte equals 8 bits. So multiply 6 by 8 equal 48 bits. So the LAN uses a 48 bits physical address written as 12 hexadecimal digits. You know the hexadecimal system? We use the numbers until 9, then A, B, C, D, E, F. For 10, 11, 12, 13, 14, 15. If you don't know, you have to go back, study what is the hexadecimal digits. What is the hexadecimal system? This is interesting. I like to convert from system to system, the numeric systems. The binary, from binary to hexadecimal, from decimal to hexadecimal, and so on. So every byte, 2 hexadecimal digits. Is separated by a colon, as the example in the yellow. See? This is the number in 12 hexadecimal digits. Physical address. This is a physical address. Then, an example in the figure 220 shows a part of an internet with two routers connecting 3 LANs. 3 local area networks. Each device, computer or router has a pair of addresses, logical and physical, for each connection. For each connection, there are logical and physical. In this case, each computer is connected to only one link in the figure. Each computer is connected to only one link and therefore has only one pair of addresses, logical and physical. Each router is connected to 3 networks. But in the figure, only 2 are shown. So each router has 3 pairs of addresses. 3 pairs. Each pair has logical and physical address. 3 pairs, 1 for each connection. So as we see, the first sender has address, physical address 10, and the logical address AP, connected to the LAN. Then the router 1, is connecting LAN 1 and LAN 2. So it has 2 pairs of addresses. Then router 2 connecting LAN 2 to LAN 3. So it has 2 pairs, logical and physical. And we have the receiver, which has the receiver has the data, the physical address 95. So it receives the 95, the router 2 deliver the frame with number 66, this one, as you see, to the receiver. This is how each router or each device, either computer or router, what we have on the network, we have routers and computers. Each device, router or computer, have connected to another one. We call each one is a node. So the computer is a node, the router 1 is another node, router 2 is another node, and the receiver, which is the computer 90, is another node. So each device have a connection. The first one have 2 pair of addresses because it's connecting one connection. The router should have 3 connections with the 3 pairs, but the figure shows 2. Each one should have physical and logical addresses. So the 2010 is what is the physical address, and the upper one, which AP, is the logical address. Ten is the physical address of the computer, and the 20 is the physical address of the receiver. Here, The receiver of the first frame from computer 10, address 10, is sending to the router. The router with number 10. 10 sends to 10. These are sender and receiver. Sender is 20 and receiver is 10. The last router, router 2, delivers the packet with physical address 66 to the receiver, as we see. The next example shows two computer communications. Two computers communicating via the internet. Only two computers, so this is more easy, this figure. The sending computer is running 3 processes at this time with port addresses A, P, and C. We said the port addresses, by port addresses we mean the applications. Each application connecting via its port address. The receiving computer is running 2 processes at this time. By process, we mean application. Like the process can be the Internet Explorer, the process can be the WhatsApp application, the process can be a Telegram application, and so on. So the receiving computer is running 2 processes at this time with port addresses J and K. Process A in the sending computer needs to communicate with process J in the receiving computer. Note that although physical addresses change from hop to hop, logical and port addresses remain the same from the source to the destination. These are the 3 processes, A, B, and C, go from the sender through the application layer, transport layer, network layer, and data link layer. The same addresses, the logical addresses stay the same, which are A and J, A, P, A, J. The data as we said, the physical addresses change. The physical addresses change, but the logical and port addresses remain. The port addresses remain, do not change. The physical addresses can change. Okay, this is a rule. So the physical addresses will change from hop to hop, but the logical addresses usually remain the same. A port address is a 16-bit address represented by one decimal number as shown. This is a port address, 753. As I know, the Internet Explorer is 182. The decimal number is 182. So each application have a decimal number which represent its address. Okay?
Okay, doctor.
So we finished this chapter. This is the last slide. Any question? Any question? So everything is clear?
Yeah, doctor.
Yes. Yes.
Okay. Okay, thank you for attendance. I will take a screenshot for the attendees. Okay, thank you all. Goodbye.
Thank you, doctor.
Thank you,
Assalamu
Doctor.
alaikum.
Thank you, doctor.
Thank you, Doctor.
Thank you, Doctor.
You're welcome. See you.
Thank you, Doctor.
Assalamu alaikum.
Thank you.